Welcome. The title of today's notes worksheet is Systems of Nonlinear Equations. This is the culminating lesson in our unit on conic sections, and what we will be doing today is really just substitution and elimination. But as we all have kind of seen in this particular unit, the equations that produce the conic sections on the coordinate plane are quite a bit more intricate than some of the equations you've done substitution and elimination with before. So although the strategies will be the same, the algebra that goes behind it will probably be a little more complex. But regardless, we'll go ahead and try it out here and see what you think. I do have a couple strategies at the top that I'll go ahead and read, and then we'll just go through 4 examples, see if we can get some practice together on this, and then see if that's all right for you. So let's go ahead and look at number 1 there. Basically, you get to use your judgment. Certain systems, I would say elimination would probably be the more efficient choice. And for certain systems, I guess substitution would be the more efficient choice. You make that call. And then once you do and you solve everything and you're feeling good about it, just make sure you do check your solutions. As a matter of fact, just a little asterisk next to that one. So check your solutions in both equations. When you've solved systems before, they've been probably linear in nature, and you could probably get away from them for the most part not doing this. I mean, I'm sure your teacher told you to do it. But in this case, you really have to be careful that they work in both. So we'll go ahead and do that. So let's go ahead and get into example 1 that I see on my board here. And as a matter of fact, this would be the first conic section. Both equations would produce that first conic section, which would be circles. So the top equation would produce a circle on the coordinate plane. The bottom equation would produce a circle on the coordinate plane. And graphically, what we would be doing is seeing where they intersect. We'll be going ahead and solving this algebraically, of course. So the question then is, do we want to use elimination or do we want to use substitution? And we'll go ahead and write that in here, by the way. And in this particular case, I'm seeing kind of an x squared above that x squared and a y squared above that y squared. We can eliminate those pretty quickly. I'm going to go with elimination. I also kind of see a variation on substitution with this, and if you see that as well, you're more than welcome to go ahead and do that, and you'll probably get to the exact same position that I would get to. But I'm going to go ahead and basically multiply this top equation by -1, and especially because it's the first time doing this, I'm going to go ahead and rewrite my system. So if I go ahead and multiply that top equation by -1, I end up getting something like this right here. And then, of course, I'm going to add that on to the second equation. And this works, of course, because of the equality in both equations. So something like that. So let's go ahead and add this onto this and this onto this. And because everything is in equilibrium, we can go ahead and do that. And I'm going to go ahead and put my plus out in front. So if you remember that elimination method there, you know, these are going to cancel, these are going to cancel. And so that was kind of the point of this, getting rid of some stuff. And I got 0y plus 4y. That would be equal to that. -8 plus 0 is equal to that. And notice, you know, a nice goal right there. What we wanted to do is kind of reduce this system from 2 equations and 2 variables to 1 equation and 1 variable. And I've done that very nicely and efficiently right here by elimination. So I go ahead and I solve for y. And of course, y is equal to -2. And that shouldn't be a big deal. Now again, at this stage, what we want to do is be a little careful. It's a little more complicated than what you've seen with linear systems before because of the solutions that we're going to get. But I think everybody would probably be in agreement that -2 has to go back in for y in either equation. I'm going to put it in the top equation. But as I said, there are just so many different ways you can pull this off. But in essence, I'm going to get something like this. Instead of x squared plus y squared, we do know it's going to be x squared plus -2 squared. And then equals 8 right there. And that's looking pretty good. I'm going to go ahead and expand this out a little bit. We should get our 4. Have it as x squared equals 4 sound to you. And then here's where you do want to be careful. We've worked a lot with quadratics. And all of these equations that we've seen, of course, are what are called quadratic relations. They're not functions, but they are relations on the coordinate plane. And so just remember when you do solve a quadratic, particularly undoing the square, and let me go ahead and get rid of that piece for just a sec. When we go ahead and undo the square right here, square root, don't forget to take the plus or minus, long story short. Okay, now that looks good. Now we do want to do a little interpreting here because I've got multiple answers for x, and I do want to correspond that with y. And so in this case, it looks like when the y is -2, x can be plus or minus 2. So the way I'm seeing this initially, and before I go ahead and get formal with my solution set, it looks like potentially 2, -2 would work, and also -2, -2 would work. So let's be careful on that. Again, what I would do is go on back, just to make sure. So put in 2 and -2. And when I do that, I get 4 and 4. That makes 8. Put in before we do the second ordered pair, let's do the 2 and -2 here to see if it would work. So let's put in 2 for x. So I'd get 4, -2 for y. And so I would get 4 again. So 4 and 4 make 8. And then with y being -2, it looks like in this particular situation I would get -8. So 8 and -8, this works. I'm liking this one right here. I'm going with it. Again, just check. I'm doing it just off the top of my head. If you need to write a few things down, please do so, please. Now what I would also do is check the second order pair just to make sure. And so -2 squared and -2 squared, that's good. That's going to be 8. And then what I would do is check it in one more time. It looks like if I do -2 squared and -2 squared, that should give me 8. And then 4 times -2, so that's -8. This looks good. It's a winner. Just have to be a touch careful. If you saw that going in that both would work, then that's great. I don't mean to overplay this by any means, but just check those solutions. And as a matter of fact, just graphically for this one, you can kind of write this or not write this. It's your call. But basically, again, 2 circles on the coordinate plane. I don't know what they look like per se. I'm not going to go ahead and sort of illustrate it. But, you know, just in very informal drawing, it looks like 2 circles can intersect at 2 points, kind of like that. Again, just based on this, have to go into more detail on that. But that would be a way that 2 circles can intersect at 2 points. And here are your 2 points right here. All right, good. Example 1, elimination, broke it down very, very nicely. And we got multiple ordered pairs. Okay, let's go get number 2. Number 2 looks like a line and an ellipse, as a matter of fact. Line and ellipse. And so how are they going to intersect on the coordinate plane? What would that look like, et cetera, et cetera, et cetera. All right, well, what do you think here? Substitution or elimination? Your call. I think one really is just so much more apparent than the other, but that's just me. I'm going to go ahead and take the substitution approach. Looks like it's kind of begging to be had there, in my humble opinion, because it looks like if y is equal to 2x plus 1, and you've seen me do this before, well, I'm going to circle that 2x plus 1 and draw the arrow right in for y. And so that's what I'm seeing in this particular situation. That should substitute nicely in for there. And then as a result, we can get down to one equation, one variable, and that, everybody, should be our comfort zone, even if it's a tough-looking equation. So that is what I'm going to do. And now, obviously, what we want to do is solve for the single variable left. In this case, it's x. So let's go get them. I've got a 2x squared right here. And then don't forget, FOIL this out, please. Don't just do this squared and that squared. That would not be right. This is 2x plus 1 times 2x plus 1. If you were to FOIL that out, and you can do that off to the side if you need to, or right down here if you need to as well, I'm getting, and let me go ahead and remove that parenthesis. So I'm getting a 4x squared. How does a 4x sound? And a 1. Okay, not too bad. And oops, I set that equal to 0 accidentally. Wasn't thinking. Sorry about that. Let's go ahead and quickly fix that for you. So that's equal to 1. There we go. Now I feel better. And let's go ahead and kind of bring this on over. These are quadratics, so combine like terms. I get a 6x squared. Looks like I get a 4x. Subtract the 1, and that's equal to 0. So that's kind of nice, as a matter of fact. Looking pretty good so far. Now, just good old-fashioned quadratic equation. Go through your methods of solving. You're going to hope, for the most part, that these factor. I'm going to hope that this one factors. And I'm looking at these two terms, and I'm seeing a 2x coming out of them. I'm not sure what you see, but a 2x looks good to me. And when that 2x comes out, it looks like I get a 3x and the 2, and then that equals 0 right there. And that's good. It's a great position to be in. Factors set to 0. We've been talking about that a lot. So we apply the zero product property on this, set those factors to 0. I've got good news right here, and I've got good news right here. Not the best answer around, but I think it'll play. And so we have two values for x in this particular case. We do want to figure out what we're going to do with them. So x is 0. Well, probably want to plug that 0 back in. And again, the question is, where do you want to plug it in? So you probably want to try to find the most efficient spot, the most clean spot. And in this case, I'm seeing it right up here. I think we can go ahead and play that out nicely. So if x is 0, really I would just kind of play this out as, all right, the y is going to be 2 times 0 plus 1. And the y is going to be 1. So I'm thinking a 0, 1 might be part of our solution set. We should go ahead and check that. So let's go look at it in the other equation. And if x is 0, this would be 0. And then if if y is 1, this would be 1. 0 plus 1 is 1. So this is a winner. And I'm going to go ahead and begin the process of putting it into the mix. And I'm going to come back to this idea momentarily, but this looks good so far, so I want to keep playing this out. But basically, what happens now if x is negative 2/3? So I'm going to go ahead and do 2 times the negative 2/3, and then plus the 1. Again, not the best answer around, but it should work out all right for us. In this case, let's see if you can do a little mental math with me. 2 times negative 2/3 would actually be negative 4/3. 2 times negative 2, so negative 4/3 and negative 4/3 plus 1, or negative 4/3 plus 3/3, I'm getting a negative 1/3 as a result. So what I saw there is negative 2/3 for x, negative 1/3 for y. It looks like that's going to be the point on this line. We should go ahead and check it right there. If you'd like, I can go ahead and do that. But let's see, we've got x is negative 2/3, so I'm getting a 4/9 when I square it, and times the 2, so that should be 8/9. And then when I square negative 1/3, that would be 1/9. So everyone, I'm getting an 8/9 and a 1/9, and that should be 1. That's looking good. I think that's a good answer there, and I'm going to keep it. If you run across something that contradicts that, let me know, but I'm pretty confident with that piece, and that seems to be our solution set right there. Now, a couple things to note before we move on to the next problem. I'm curious if you would have potentially done something a little different. Now, I would encourage you, don't write what I'm about to write here. In fact, I'm going to erase it after the fact. But let's go back just 1 second if it's okay with you. What if I said, all right, the x value is 0, and what if you forgot to put it in here and you said, you know what, I'm going to put it in here instead. So here's just something that can come up with this. And, you know, if you're like, oh, I wouldn't do that, then that's fine. No, you know, no worries at all. But what if you said, all right, I'm going to try it in that quadratic, which is okay, of course. You would do 2 times 0 squared, so this is just 0, and you end up getting y squared equals 1. And you, of course, have been taught to undo a square with a plus or minus. And you would end up getting 2 answers there, right? You would get 1 and negative 1. So officially you would be thinking, all right, well, it's got to be 0 and 1 and 0 and negative 1. And you would include both of those in your solution set. And you would be right. Those two values work in this equation. But the question is, do those two values work in both equations? And here's what I've seen come up over the years is exactly this, not checking. And you would see, of course, that if you were to put this back in the line, well, if x is 0, can we have a y value of negative 1? No. That's why we check. So we got away with it because we put it in the line right there, and it worked out pretty cleanly. Not a problem at all, but you have to be careful. You just never know. So I hope that makes sense. I'm going to erase just so this doesn't get in our way, but I hope at least that description makes sense on why we check. Because you could do all your math correctly and get something that still doesn't work as part of the solution set. By the way, just in terms of this ellipse, graphically, I don't know, I think it's something like, here's an ellipse, here's a line, you know, 2 intersection points, something like that. I'm, again, just kind of making stuff up on the spot there, but that would sort of be the case. 2 points, 2 intersection points right there, so 2 ordered pairs. Okay, let's go get 3. Let's see, 2 hyperbolas as a matter of fact. Interesting. So 2 hyperbolas, I'd ask you, which way do you want to go, substitution or elimination? I personally believe one fits better than the other, but you know, it's just what I see. And I like the elimination here, just looking at this. But if you want to pursue a different route, of course, go for it. So I'm going to take a look at this. You can work with eliminating the x's or eliminating the y's. I don't know. I'm going to go ahead and multiply this bottom equation by -2. That way I'll have a -2y squared, and then I should have a positive 2y squared. So that's just how I'm thinking of it. But as mentioned, there's so many different paths with these. You go with what works for you. So negative 4x squared, I did want that as a 2y squared, and this will turn out to be 4. And I think it's ready to go. Nice goal with elimination is to get rid of one variable, so you're down to one equation and one variable, and I think this will work here because I'm going to get a negative 1x squared. These are going to vanish, and I'm going to get a negative 1 right there, and this is something we can manage nicely. Everyone okay bringing that negative on over to the other side? So dividing by -1 now makes that accessible to us. So I'm going to go ahead and square root and square root. And a plus or minus 1 looks nice, at least initially there. So I don't see, you know, one equation here being better than the other dealing with these. But let's go ahead and see what happens when I go ahead and put that 1 in. Hang on one sec. I got just a touch ahead of myself. So let's start with putting 1 in and see what happens. So if x is 1, I'm just going to do it in the top equation. So 3 times 1 squared minus 2 times y squared equals -5. Again, no advantage one way or the other here, but you know the 1 has to go in. And so let's go ahead and see what happens here. 3 times 1 squared is 3, so I get that. Again, I hope you're following and you're feeling pretty comfortable with either substitution or elimination. We did elimination, and now it's a matter of putting that number back in. I'm going to go ahead and subtract 3 on both sides, so negative 2y squared. Subtract the 3, and I'm getting a -8 on that. What do you say we divide by the -2 there? So y squared equals 4. And then y equals, oh, this is interesting, plus or minus 2. All right, so we put 1 in, and we ended up getting 2 y values here. Let's explore that in a little more detail. So that should work for the top. If I put 1 in, notice 2 works or -2 works, because if you square 2 and -2, you're going to get the same result. So I'm hoping everyone sees that in the top equation, and that's what we use, that top equation, plus or minus 2 is in play. Does the 1 with the plus or minus 2 work here, everybody? What do you think? Well, if I put 1 in, we can do that. 2 times 1 squared is 2. Bring that on over, of course. And so I'm going to get a -4. Divide by that negative. I get y squared equals 4. Ah, look at that. Same thing would occur. So I'm hoping you see that both are valid right there when I put 1 in. Now I'm wondering if you can kind of think quickly with this one. I'm not sure. But think about this. What would happen if I put the -1 back in? Because I still have to do that, everyone. That's what makes these a little more complicated, more steps. But I have to put the -1 back in for x too. Well, guys, what would it look like if I put -1 back in for x? Wouldn't I? And let me write it first before I say it, but I'm hoping you're thinking it. Wouldn't I get the same result? Because squaring 1 is the same as squaring -1, and that's sort of what's happening here. Everything's being squared. So, you know, if I put a little ... on this, aren't I also going to get y is equal to plus or minus 2? So when 1 goes back in, you get 2 ordered pairs, 1 and 2 and 1 and -2. When -1 goes back in, notice the same thing. Long story short, you're going to get 4 ordered pairs here. So when I put 1 in, I got 2. When I put 1 in, I also got negative 2. That was putting the 1 back in, getting 2 different y's. Also, though, I had to put the negative 1 back in, and I got the same exact thing. And that's what happens. Students over the years have asked if they could consolidate this a little bit, and absolutely. So you can write this like this if you'd like. You don't have to. I wanted to be clear that there are 4 ordered pairs, so I wrote it like that. But this basically illustrates that. And obviously, it's quite a bit more compact. So I'm going to erase this momentarily, but if you want to go ahead and write your solution set like that, I will certainly not stand in your way. Nice. Cool. What would this look like? It's funny. I think these are, I haven't investigated it, but I think these are vertical. So something like this, and then, you know, there would be one branch going up, kind of like that. So I'm seeing that as kind of like this, and then something like this. You know, it would be the 4 branches of the 2 hyperbolas, and they would intersect at 4 different spots there, something like this. That's how I'm envisioning it. I might be jumping the gun just a touch there, but we'll go with something like that. Theoretically, that's the case, and you're getting 4 ordered pairs. Great. I think we've got one more on our plate. Let's give it a go. And 2 circles again, but my goodness, watch the algebra here. Let's see if you can pull this off. This is a fascinating one. 2 circles. So the question is, what do we want to do? Substitution, elimination? I don't know. Well, I guess the first order of business for me, I don't like either, to be honest. I could get away with a little substitution or maybe elimination, but I don't know. I think something has to come out first before we can even think substitution or elimination. And what I'm thinking, everybody, is this equation down here, I would like to expand out and kind of see it more in its general form. Even though this isn't particularly in the general form, I would like to see this in it. So long story short, let's go ahead and expand that out. I don't mind taking the lead on this. And let's do x minus 5 squared, which would be x squared minus 10x plus 25. I'm going to do the same thing here, guys. Let's go ahead and expand that out. That would be a y squared and a minus 10y and a plus 25. And that equals 10, just from what I see. Okay. I'm going to clean this up a little more and then bring down that other equation, and then let's see what we want to do from there. I'm going to go ahead and bring the 25 and 25 on over to this side, if that's all right with you. So I'm getting an x squared plus y squared minus 10x minus 10y. Now this was a 50, so I'm going to do 10 minus 50 here and end up getting the negative 40. All right, I hope everyone kind of saw that one step. So here's the 25 and 25, which makes 50. I'm taking that 50 and I'm going to bring it on over to the other side. 10 minus 50 should be this. All right, now I'm trying to be very organized with what I see here. This is looking pretty good to me, something like that. Now, you know, again, we can go either route here, to be honest. I guess the more formal approach would be just a little elimination. I'm going to go ahead and multiply this by -1 and put the plus out in front, if it's okay with me, with you, if I consolidate these 2 steps here. I'm going to do elimination, long story short. So after I expanded it out, I think elimination is a good way to go. So unfortunately, there are no easy answers on this one. But when I go ahead and do this, x squared plus -1x squared, these are going to cancel. These are going to cancel. I'm going to bring this on down. I get negative 10x. Bring this on down. I get negative 10y. And I do want to be careful here. This is a negative 20. So if I add those together, I end up getting negative 60. Now here's what's kind of fascinating about this particular problem. Our goal always, you know, with substitution or elimination, is to reduce it to one equation, which I've done, but one variable. And if you notice, I have an equation here, but unfortunately, it's got 2 variables in it. And that's not very user-friendly. So I'm curious what you see. Any thoughts? Well, I'm thinking we can now start to pursue a secondary step where we can go ahead and get one variable at least by itself. And so what I'm thinking here is I'm going to bring that, well, I can do this a couple different ways, but I'm going to go ahead and solve for y right here. So I'm going to do negative 10y equals, and I'm going to bring that over 10x minus 60. I'm going to divide by negative 10. So divide by negative 10. And I'm hoping you see kind of this. This would be a negative 1x, and this would be a plus 6. If it's okay with me changing the order, I get something like that right there. Y is equal to 6 minus x. All right. Now, not great. Not thrilled to be kind of going through a secondary step here. But now at least I have y is equal to 6 minus x. And of course, then I would ask you, if this is just great algebra, nothing more, what would you do with that 6 minus x? Well, if it's equal to y, then you know it can replace a y. And I'm going to go ahead and draw my arrow all the way in. I'm seeing a decent spot for it. I'd like that top equation better, but I'm thinking something like that would do. So it's going to go all the way in there. And now, when it goes in, I do have one equation and one variable. Oh my goodness. But it is ready. So I'm going to have to now play it out a little bit. I'm going to try to find myself as much room as possible here, but basically instead of y squared, it's going to be 6 minus x squared. Great algebra. This is, exactly what we've been working on all semester long, solidifying those algebraic skills and really following your organized work from beginning to end. So let's go ahead and keep playing it out. I hope everyone's all right at this stage. So I'm going to go ahead and do this. This is a great looking quadratic equation. So FOIL this out. I don't mind foiling it out with you. But I get 36 minus a 12x and plus an x squared. And that should be equal to 20. All right, how do we deal with every quadratic equation? What should be our default position? We should always set it to 0. So x squared and x squared make 2x squared. Minus the 12x, and then I'm going to go ahead and bring that 20 on over. 36 minus the 20, so I'm getting a plus 16. If you want to go quadratic formula on this, I will not stand in your way. It is ready to go. I wouldn't mind kind of seeing it from beginning to end here myself and just seeing if I can work it out. I see that I can sort of divide everything by 2. It is an equation, perfectly okay. So x squared minus 6x plus 8. Again, if you want to cop out there, not that it's a big deal, but if you wanted to go ahead and use the little quadratic formula right there, it works. But I see this working nicely anyway. So I'm going with, how about an x minus 4? How does an x minus 2 sound? And lo and behold, I've got these two right here. Okay, very good. Am I done? Sadly, no. I've got to go ahead and figure out where to put them. Now it's your call at this stage if you want to go ahead and kind of pause the video and put it in and then see if you can get some good results. That's perfectly fine by me. I will tell you there are only 2 answers to this if you decide to pursue that. So this is one of those where you've got to make sure it works in both of them. All right, I'm going to go ahead and put it in the top and then do a little checking there. So if I put 4 in the top, I get 4 squared plus y squared equals 20. Not a big deal. This is 16, and so subtract the 16 and I get that. And so I'm looking at plus or minus 2. So when x is 4 at this stage, it looks like it could potentially be 4, 2 and 4, negative 2. Here's the thing. Unfortunately, not both of those work. So I'm going to check. We're getting close to the end here. I'm going to make sure that I do this correctly, though, before we wrap this up. So let's see which one potentially works. Again, good mental arithmetic. If you need to write things down, please do so. I'll see if I can do a couple things in my head. So 4 minus 5 is negative 1, negative 1 squared, so this would be 1. And then 2, so this would be 2 minus 5, which is negative 3, and negative 3 squared is 9. So I got a 1 plus 9, yeah, 10. I like it. It's a winner. 4, 2. I am pretty confident that that is one of the answers. Let's go ahead and check 4, negative 2. Same deal. 4 minus 5 is negative 1. Negative 1 squared is 1. So this is 1, everybody. But negative 2 goes in. Negative 2 minus 5 is actually negative 7. Uh-oh. Negative 7 squared is 49. Does this one work, everybody? No. Axe it. Get rid of it. Don't like it. So that's why we check. It worked in the 1. You know, I would have thought it was plus or minus 2, but it's not. All right, guys, we're almost done. Let's get the 2 in. 2 squared plus y squared equals 20. Same deal. This is just going to be 4, so I get y squared equals 16. At this stage, y seems to be plus or minus 4. So what you're thinking is, all right, 2, 4, and 2, negative 4. I do need to make sure. Again, it would be just a shame you do all this work correctly, and then at the very end, you don't get the right solution set. So let's go ahead and put it in. I don't mind taking the lead on it. If I do 2 minus 5, I get negative 3 squared. So the 2, 4 looks actually very similar to what I did before. I think that's working. You would just get the 9 plus 1 right here. I like this one. 2, 4. Let's see that 2, negative 4 just to make sure. So 2 minus 5, so this is 9 right here when I put 2 in. And negative 4, well, unfortunately, negative 4 minus 5 is negative 9. Negative 9 squared, too large. And so this one goes. And guys, that's our solution set. A ton of work for that, but you know, we're always trying to raise the bar with this stuff, and bar has been raised. That's some great mathematics that goes into that problem. So this was the 2 circles. Probably a couple other ways 2 circles can intersect. Ooh, that was a terrible drawn circle, but you get the idea. 2 spots, and there are your 2 answers. All right, guys, well, just a nice way to end conic sections there. So circles, ellipses, parabolas, hyperbolas, all now just kind of looking at them and solving them as a system. You've done linear systems before. These would be called, of course, nonlinear systems, quadratic in nature. Hey, thanks for listening. Try some out. There's some, you know, relatively straightforward ones, and then there's obviously some that are really a little above and beyond, like this one that we just did. So try them out. Get some practice with it. See if you can pull it off. And thanks, of course, always for listening. Excuse me.